Welcome everyone to today's webinar from PHA LOPA to SIL, translating risk analysis into SIL selection and verification. I'm Stephanie and I'll be your moderator for today's session. Couple quick housekeeping notes before we begin. Today's webinar is being recorded and we'll make the recording available to you in the next few days. Please submit any questions using the Q&A box in Zoho webinar and we'll address them at the end. Charlie will be presenting for about 30 minutes and we'll reserve the last 10 minutes for your questions. Please take a moment to review the disclaimer on your screen. The webinar is intended for informational purposes only and does not constitute professional advice. The views expressed are those of the presenter and do not necessarily reflect those of Accutech Group. This session is being recorded and by participating, you consent to that recording. Today's webinar is the third and final session in our functional safety series, and it was shaped directly by your feedback. The topic came out on top in the polls that we ran on LinkedIn and during webinars 1 and 2, so you chose what we're covering today. And if you've missed either of the first two sessions, both recordings are now available on our website. Links will be on the screen at the end of today's session. For those joining an Accutech webinar for the first time, a brief introduction. Since 1994, Accutech's been a global leader in consulting, training, and software solutions for process risk management. We bring deep expertise in both the management and technical aspects of risk, working with organizations ranging from the world's largest companies to government agencies, all with the goal of improving safety, security, environmental, and operational performance. So let's get to what we're covering today. For many PSM leaders, PHA and LOPA are on one side and SIL selection and verification on the other side are very closely related activities, yet the connection between them isn't always as clear as it should be in practice. So today, Charlie will translate that relationship into plain language. We'll explore how PHA and LOPA results should inform SIL selection and how SIL verification then confirms that SIS performance actually matches the intended risk reduction. Along the way, we'll address one of the most common points of confusion in this space, why a high PHA risk ranking does not automatically mean a high SIL. The goal today is practical and direct to help you build a clearer, more reliable connection between your risk analysis work and your functional safety decisions so that both your PSM program and your SIS program are stronger for it. So returning for the third and final session of the series is Charlie Souza, Accutech's functional safety lead. Charlie brings over 25 years of engineering and consulting experience in instrumentation, controls and automation, functional safety, and industrial cybersecurity. He's a licensed professional engineer, a project management professional, a certified automation professional, and holds both IEC 61511 Functional Safety Specialist and IEC 62443 Cybersecurity Specialist certifications through ISA. Charlie leads Accutech's SIL verification practice and is a founding member of the ISA Global Cybersecurity Alliance and a member of the FBI's InfraGard program. And for those who have been with us through all three sessions, thank you for sticking with us through the series. And if today's your first time joining us, welcome. This session's designed to stand on its own, but you'll find links to webinar 1 and 2 at the end if you want to go deeper. So Charlie, the floor is yours.
All right. Well, good morning, afternoon, everyone. Thank you for joining the third and final webinar in this functional safety series, especially for PSM leaders. As Stephanie said, we've had 1 and 2. The recordings are available. You don't have to watch them in a particular order, but it is helpful to watch all 3 of them. As you will see, some of our slides, some of my comments will pull from definitions that I clarified in webinars 1 and 2. So today, this one from PHA LOPA to SIL, we are going one. So if I could go back and talk about the first webinar. The first webinar, for those of you who are not here, we discussed why functional safety belongs within the PSM program and why safeguards credited in PHA and LOPA must remain valid in the field. So that was the entire point of webinar 1, is how to make sure that from the beginning to end, things make sense, are coherent, right? And how to make things defensible or prepare for an audit program. In the second webinar, we discussed how functional safety assessments, or FSAs, can review hidden SIS risks that may not be detected by a traditional PSM audit. I conduct PSM audits myself, and they only touch the tip of the iceberg when it comes to functional safety. And as a reminder, something that I reminded the audience in webinar 2, considering that our audience is not technical in nature, at least the majority of those attending are PSM leaders, PSM managers. So the reminder that I made is that as PSM managers, you are responsible for functional safety, even if it is one of the sub-elements of the PSM elements. It is there is context to it. There is part of it. It does fall under the PSM elements. Therefore, you are responsible for it, whether you know it or not, right? So the reason behind the 3 webinar series is to give you a 360 view of what you're responsible for, right? What questions you should be asking. So if webinar 1, we discussed that functional safety belongs within PSM program. Webinar 2, we discussed functional safety assessments and how they can review hidden SIS risks. Today, we're going one step upstream. We're going to look at how the risk analysis works. Many of you already know as PHA and LOPA, or HAZOP and LOPA. We use PHA because you could be using other techniques than HAZOP. But you already know that PHA and LOPA should connect to SIL selection and SIL verification. Now, one thing I want to clarify right at the beginning is this is not a webinar about converting a PHA risk ranking directly into a SIL, or safety integrity level. That is one of the misconceptions we're going to discuss today. The real question is, how should risk analysis inform the performance requirements we place on safety instrumented functions, and how do we verify that those requirements are actually being met? So how does this complete the series, right? Still kind of giving you a little review of what we've seen before. This webinar completes the series by tying together the themes from the first 2 sessions. Like I said, the key point, let me put it in a different way. The key point of webinar 1 was that functional safety should not live outside the PSM program, which I see a lot out there throughout my 20 plus years of experience. So if the HAZOP and the LOPA credit safeguards, and we're very familiar with HAZOPs and LOPAs, and we do know they fall under, they are, a part of the OSHA PSM elements. If we credit safeguards, those safeguards have to be managed through mechanical integrity, which is another element, management of change, operating discipline, training, testing, and documentation. So if we are crediting safeguards, we are talking about functional safety. So webinar 2, we discussed the FSAs, as I said, where it can uncover gaps in documentation, in validation, proof testing, independence of protection layers, and other assumptions. So today we're looking at where many of those findings begin. So if webinar 2, we gave examples of findings that can be picked up by functional safety assessments, which are not PSM audits. And that was the point of webinar 2. Even though you're executing, you're conducting your PSM audits periodically, that's just covering the tip of the iceberg when it comes to functional safety, right? So that's where functional safety assessments come into play to bring issues to the surface, especially systematic issues. So today we're looking at where these findings come from. Where do they begin, right? So often they do not begin at the final calculation. they begin earlier when the scenario basis is unclear, when IPLs or independent protection layers credits are inconsistent, when SIL targets are assigned without sufficient traceability, or when verification is performed without a full understanding of the assumptions behind it. So the progression is simple, right? Functional safety belongs in PSM, FSAs review hidden SIS risks, and risk analysis must connect to SIL selection and verification. So when I say high risk does not automatically mean high SIL. So this is probably the most important concept of today's webinar. A high PHA risk ranking does not automatically mean a high SIL. That may sound counterintuitive at first because we're used to thinking of higher risk should mean stronger protection. So I'm going to have an elevated SIL. And generally, that is true. But SIL is not simply a label we assign because a scenario has a severe consequence or falls into a high-risk box on a matrix, on a risk matrix. A PHA risk ranking is usually a screening and prioritization tool. It helps the team assess the severity and likelihood of the scenario and decide whether additional analysis or risk reduction is needed, which is exactly the difference between HAZOPs and LOPAs. Is in HAZOPs you identify those high severity or high likelihood scenarios, and you take only those to LOPA. And in LOPA, you do a more quantitative or semi-quantitative study in which you determine what residual risk is still still exists, right? And the safety instrumented function or functional safety, that layer comes to close that gap and eliminates the residual risk. So if the PHA risk ranking is that screening and prioritization tool, SIL, on the other hand, is about the performance required from a safety instrumented function. It is tied to the amount of risk reduction that the SIF must provide after considering that specific scenario, the initiating event, the consequence, and any valid independent protection layers. So when we bring those high likelihood, high consequence scenarios into the LOPA, and we take credit for all of our independent protection layers, if after taking credit for all of those, we still have residual risk, then we size that residual risk, and that translates, or that tells us that we need a safety instrument function. And the SIL level, the safety integrity level, it is based on how big that gap is. So that gap, you may have a high consequence, high likelihood scenario, but you have a mechanical protection. You have your BPCS. You may have a BPCS and a DCS. So and therefore you may end up with a SIL 1, with a low SIL, or no SIL at all, even though you started with a high consequence, high likelihood scenario. And the opposite is also true. Sometimes there are scenarios that are not so high in severity and likelihood, but you don't have any protection against it. There is not much you can do in terms of your BPCS and in terms of mechanical devices. You must rely solely on the safety instrumented system. And that causes the SIL level, the safety integrity level, to be high, because you don't have any other independent protection layers. So the missing question is not simply what risk box are we in? The better question is what risk reduction remains after we account for credible and valid protection layers. What each step is really doing. So to make sense of the alignment problem, and this is something that a lot of PSM managers can't visualize. right? So I decided I'm a visual person as well, so I decided to lay out the slide the way it is to try to give a visual picture of what I'm trying to explain. So to make sense of this alignment problem, it helps to separate what each activity is actually trying to answer. So on the PHA, we're asking what can go wrong, right? It identifies hazard scenarios, causes, consequences, safeguards, as we said, recommendations, those responsible for closing those recommendations. It's the foundation of risk discussion. LOPA, we are asking how much more risk reduction is needed if we don't have enough risk reduction, if we haven't been able to find or credit enough risk reduction during the PHA. So the LOPA examines selected scenarios, and when I say selected, let's think of those high consequence, high likelihood scenarios, only the scenarios that stand out and still present residual risk that we could not close during HAZOP. So those are selected scenarios, and it examines and evaluates whether the existing safeguards and independent protection layers are sufficient to reduce the risk level to a tolerable one. And SIL selection, in SIL selection, we ask if a safe instrumented function is needed. Again, if we end up with a gap, we cannot close this gap. So we need a safe instrumented function. So if that SIF is needed, what performance is required from that SIF? This is where the required risk reduction assigned to the SIF is translated into a SIL target, a safe integrity level target. And finally, in SIL verification, we ask, can the design actually meet the target? So that means looking at the architecture, devices in terms of sensors and final elements like valves and pumps, VFDs, what have you, and looking at failure rates, diagnostic coverage, proof test intervals, common cause factors, and other factors that affect the probability of failure on demand or the dangerous failure rates. So again, the last one, the SIL verification, we are looking at the design and analyzing the design, verifying that the design will meet those requirements of that SIL level. The important point for PSM leaders is that each step depends on the quality of the preceding step. So if the PHA scenario is poorly defined, LOPA becomes unstable, as we say it. If LOPA credits weak IPLs, independent protection layers, maybe you're crediting BPCS twice without knowing how to do it. It is possible, but you need to know how to do it. So if LOPA credits weak IPLs, the SIL target may be misleading. You may end up with a SIL 1 versus a SIL 2 or vice versa. If the SIL target's not clearly linked to the scenario, the SRS, which is a safety requirement specifications, may be vague. And that SRS, as we're going to see in a little bit, it contains details of how fast this SIF, this function needs to operate, and some other details, how to be bypassed, and some other technicalities of the safety function. So if the SIL target is not clearly linked to the scenario, the SRS may be vague, may not contain all of this data. And if the SRS and the SIL verification assumptions do not reflect the actual field design and testing practices, the site may have confidence in paper that does not match reality, right? It doesn't matter if I tell you, or if the SIL selection and SIL verification says that we must test that transmitter every year. We can say that all day long, we can put that in paper, but if your mechanical integrity team or your maintenance team has no plans for testing that device annually, then it looks good on paper, right? But it's not, in reality, that's not what we're getting. So from scenario risk to SIS performance requirement, we start with the PHA scenario, as we said. That scenario may then be evaluated further through the LOPA. If there is a risk gap, the team decides on the appropriate protection strategy. If the selected strategy includes a SIF, then a SIL target is assigned. The SRS then defines what the SIF must do, the logic, right? When this happens, what needs to happen, right? The cause and effect, if you will, and how fast that needs to happen, how fast that valve needs to close or to open. And SIL verification checks whether the design can meet those requirements. The goal is not to match labels. The goal is to preserve the basis for the risk reduction. So we are not looking at these independently, which a lot of times it happens. Clients will come saying, I need a SIL verification, and then give me a bunch of paperwork. But if I'm just doing the SIL verification, a lot of times I don't have enough information upstream, and that creates anxiety, right? Because okay, I'm verifying the SIL, I'm giving this person confidence that the SIL works, right? That the hardware works, but it's always in the back of my mind: is the SRS thorough, right? Is the SIL target being assigned correctly? Is even the cause and consequence, even the hazard scenario, being attributed or being properly defined? So just picking one of these boxes does not guarantee that you have a effective or a good system, right? Robust system. So a strong program should be able to trace the logic from the hazard scenario through to the field performance expectation. And the field performance, we're talking about mechanical integrity, we're talking about, proof test procedures, which depending on how you test it, you're gonna reach different proof test coverages. That depends directly on how you're testing this. And the proof test coverage is a major element in SIL verification, to be able to tell whether or not your hardware is capable of providing that level of integrity. So all of these are tied together, right? Like as in a chain. So if you cannot trace the reasoning, the SIL may still look valid on paper, as I said, but it may be weakly supported. That's where organizations can end up with SIFs that appear documented, calculated, verified. We do have SIL verification, we do have SRS requirements, we do have proof test procedures, but the basis behind them is not as defensible as it should be. One example that comes to mind: you may have a hazard scenario that indicated that you need a pressure function, like a SIF that is triggered on a high pressure. And I have found by doing functional safety assessments that on that particular hazard scenario, you would pick up that hazard, or you would detect that hazard situation quicker if you look at the temperature than looking at the pressure. So we're actually putting more weight, or asking that SIF to be more robust or work faster, because we are looking at it from a pressure perspective, and in reality it should have been looked at from a temperature perspective. I understand this is kind of an abstract example, but it helps to give you an idea of things that were not captured correctly early on, and you may end up with a SIF that it is protecting you, but it may not prevent a hazard from happening. And this is also where the FSA findings come from, as I said, right? So with functional safety assessments, we're going from the very first box all the way to the last box, and we are looking at all of this documentation. We are checking and verifying and cross-checking and making sure that from beginning to end, you have the SIF that you need, and that SIF has been properly implemented and is being properly tested, and etc. So a SIF is one possible risk reduction response. One common mistake is treating a SIF as the default answer whenever a LOPA shows a residual risk gap. But a safety instrumented function is only one possible risk reduction response. So sometimes the right answer is a design change, right? If you end up with a SIL2 or maybe a SIL3 on the LOPA, that is a red flag. That means that, hey, how about we go back and look at the design and try to go with a more inherently safe design, right? Eliminate or reduce the hazard at the source. Sometimes it is mechanical protection, right? Relief valves or rupture discs. Sometimes it is improving an alarm response or doing alarm rationalization, a procedure that could be rewritten, an inspection practice, or another independent protection layer, if it truly meets the criteria to be credited. Sometimes the right answer is to challenge the assumptions before jumping to a SIL target, right? Assumptions such as probability of ignition, or is the initiating event frequency reasonable? Are the IPLs actually independent? Are they reliable? Are they auditable? Is the scenario defined correctly? Only after that protection strategy decision is made should the team decide whether a SIF is needed and what performance requirement the SIF must meet. This is important because SIL selection quality depends on the quality of the protection strategy decision. So if a SIF is assigned too quickly, the organization may over-design, spend unnecessary money, complicate operations, complicate equipment, complicate maintenance, create testing burdens by doing that. And if a SIF is avoided or underclassified without a sound basis, the facility may be underprotected. So decision quality errors, not just calculation errors. This is where the topic becomes more practical, right? Many PHA LOPA to SIL gaps are not simply math errors, they are decision quality errors. One common pattern is when matrix severity drives SIL. I have seen that before. Somebody looks at a risk matrix and says, okay, SIL2 in this region, SIL3 if it gets up here, SIL1 if it's, orange. I have seen that before. So the team sees a severe consequence and assumes that it means SIL2 or SIL3 without clearly determining the required risk reduction from the SIF. Another pattern is optimistic IPL crediting. Oh, this one is dangerous. A safeguard is credited in LOPA, but when you look closer, it may not be as independent as you thought, or it may not be independent at all from the cause, or independent from another layer. It may not be reliable enough, it may not be audited or tested, or it may depend on the same people or power or logic or equipment as another credited layer, especially when things are shared between BPCS and SIS. Or for those who prefer to take 2 credits for their BPCS systems, which again, the standard allows for, but it's a thin line to walk on, and you need to know how to do that properly. And a lot of times it's over done, or it's done more often than it should by more people than with equipment that does not meet those standards. So then there is the SRS, right? And when I talked about the vague linkage in the SRS, so the SIF exists, the SIL target exists, the SRS exists, but the requirement does not clearly trace back to the hazard scenario. And by that I mean the SRS may not clearly define the safe state, or the process limits, or the response time, the infamous process safety time that tells us functional safety engineers what the reaction time should be of that SIF. We need process team to define what the process safety time is. And I've lost count of how many times I'm given a SIL verification project or challenge, and the PST, the process safety time, is not even known. Nobody has thought about calculating it. A lot of times the process team in that project doesn't even know how to calculate it. But because of that, the lack of understanding of this from beginning to end, we don't notice, we don't realize that all these steps need to link, need to come together, right? As we saw in a couple of slides back. So, and the same thing applies to voting, to proof test assumptions, bypass management. Some of these SIFs may need to be bypassed. You have to have a bypass procedure, a robust one. It needs to be managed, all these bypasses, and reset expectations, right? You cannot reset things remotely when it comes to safety instrumented systems. Then there is a box check verification. Calculation is completed, the result passes, but the calculation is detached from the original assumptions. I've touched on that in previous slides. So in this case, the proof test interval, as an example, the proof test interval may not match the actual MI program. So if your MI is counting on only testing these particular devices every turnaround, it may not be testing as often as the SIL verification requires for that particular safety instrument function. So the scenario basis may have changed through MOCs as well, without triggering a review. So even if design changes, design basis changes or things change in the field and are not captured via MOC, or are captured via MOC, but the MOC does not require the functional safety team or does not require a competent person to review it and understand or decide that a change within the safety instrumented system or within the configuration of that safety instrumented function needs to be done, or a review is triggered of that particular function. So the key message is verification cannot rescue a weak risk basis. So just because you pass a SIL verification, that's not the whole story, right? It can confirm whether a design meets the stated assumptions, but if the assumptions are weak, inconsistent, outdated, the verification result can create false confidence. This is not just an engineering detail. So for PSM leaders, the point is not that you need to personally perform SIL verification calculations. PSM leaders, they don't have to become functional safety experts or get the same functional safety training that functional safety engineers receive. As a matter of fact, we have functional safety training for managers. We have functional safety for managers, which is a half-a-day course. We have obviously the functional safety training for engineers, which is a multi-day course, and we have functional safety for technicians, which has to do with the MI, the proof test procedures, proof test interval, explaining all of that to technicians. That is like a half a day to a full day, depending on the size of the team. But I digress. But coming back here, PSM leaders don't need to become experts. The point is that you need to govern the process that makes those decisions defensible. You're still responsible for it, right? This topic connects directly to several of the PSM elements that you so well know, right? It connects to PHA, it connects to LOPA, it connects to MOC. So PHA would be because the scenario definition and safeguard assumptions begin there, as I said. The LOPA because the risk reduction decisions depend on that IPL crediting, right? A consistent one. It connects to MOC because changes in equipment, process conditions, procedures, and all of that can be affected by MOCs. connects to MI because of proof testing, inspection practices, and frequency. It connects to operations because quite often credit layers will depend on the real world behavior of operations, right? Testing, maintenance, bypass control, and bypass management. And it connects to audits because the question is not just whether documentation exists, but whether the logic is still valid, whether that chain remains intact and has not been broken. And by chain, I'm talking about this one right here. So the PSM leader's role is governance, consistency, traceability, assumptions, triggers, evidence, and follow through, right? You need to know it exists, you need to know it's under your responsibility, and you need to assign a responsibility for others who have a more engineering or technical responsibility over functional safety. You do not need to be an expert, as I said, but you should know what questions to ask and when the chain of reasoning may need review, right? That chain. I'm gonna skip this example here real quick. We'll go back to it if we have time. But what SIL verification does and does not prove. This is an important distinction. SIL verification confirms that the calculated SIF design meets the target SIL under the assumptions used in the calculation, which includes the architecture, device failure rates, diagnostic coverage, proof test interval, etc., right? Other design factors. But verification does not prove that the original scenario was correct. So as you can see, I'm emphasizing on that, right? Original scenario versus SIL verification. It does not prove that the LOPA credits were valid. It does not prove that the SRS was complete. It does not prove that the field proof testing matches the assumed interval or even effectiveness, talking about proof test coverage. And it does not prove that the MOC is managing the changes on the basis. So a correct calculation can still be attached to a weak basis. And that's why verification is necessary, but not sufficient on its own. It has to be connected to the PHA, the SRS, field testing, overall life cycle management, right? So red flags for PSM managers. So these are signs your PHA LOPA to SIL chain may need review. Here are some practical warning signs for PSM managers. And these you can take back to your organization. So if SILs are assigned without clear traceability to specific hazard scenarios, that's a red flag, right? If you have a SIL that you cannot link correctly to a hazard scenario, or it's not fitting that the protection or the prevention of that hazard scenario, that's a red flag. If the LOPA assumptions vary significantly across units, so you have LOPAs with different facilitators, different units within the same company, different projects. So if those assumptions vary, that's a red flag, right? Some units giving 2 credits for BPCS, others giving only 1 credit. Check valves with the similar technologies. Some follow that, some don't. So those are red flags if things are done differently LOPA-wise. If the SRS doesn't clearly link the SIF to the analyzed scenario, safe state action, response time, everything I mentioned before, that's a red flag. If verification is performed late, this is a very common one. If verification is performed late, which by late, I mean after design freeze or just before startup, that is a red flag. And it is a red flag not only technically, but financially, right? Because by then, any gaps may be much more complex and expensive to correct. So then we have to deal with budget. Budget is gone, and it's harder to fix things, right? It's easier to apply an incomplete solution to it. If MOC does not trigger a review of SIL basis or IPL assumptions, that is a red flag. And last but not least, if proof test intervals used in verification do not match what maintenance actually does in the field, that is a major red flag. So the issue is not whether paperwork exists, and we talked about paperwork on our first webinar, and the second webinar for that matter, when we talked about functional safety assessment. Most sites will have paperwork. Well, I say that loosely because there are plenty of sites without even paperwork. But I like to say that most sites have some paperwork. The real question is whether the logic still holds, the quality of the paperwork, the accuracy of the paperwork, the applicability, and how fresh that paperwork still is, right? How applicable that paperwork still is to your situation, to your scenario, to your current conditions. So if several of these warning signs apply, the site may benefit from a LOPA SIL assignment review. You need to do something, right? Either an assessment, functional safety assessment, or a LOPA SIL assignment review. Get your facilitators in the room and what's going on. We are taking credits, differently across units, across projects. You may need the SIL verification support, or even an SIS health check altogether, which would be an SIS audit done by an external facilitator, for example. Or if you are a large corporation, you may get someone from a different unit, different facility altogether, or different continent to come do an internal audit for you, someone who is not biased by your leadership in that particular facility. So what PSM leaders should ask for? Well, if you are a PSM leader, these are the questions, the type of questions that help improve governance. Can each SIF be traced back to a specific analyzed scenario? Are IPL credits consistent, independent, reliable, and auditable? Does the SRS clearly state the action, the safe state, the response time, process limits, proof test assumptions, and reset expectations? Does the SIL verification use assumptions that reflect the real field installation and maintenance program? And do MOC and MI processes trigger review when assumptions change? If those questions are difficult to answer, the program may be carrying hidden SIS risk, right? But the goal here is not to create more paperwork. I want to emphasize that. The goal is to ensure that the risk reduction claimed in the analysis, right there in the beginning, is still supported by the design, the current design, and sustained in the field by operations, by maintenance, etc. So as key takeaways, aligned programs make better, more defensible risk decisions. So in closing, we can take away that SIL is not a direct translation of a PHA risk ranking. A high risk matrix result does not automatically mean a high SIL, as we discussed. Second, the PHA and LOPA should establish a traceable risk basis. The scenario, assumptions, initiating event, consequence, the safeguards, the credit IPLs, they need to be clear enough to support the decisions that follow. They can vary much from unit to unit, facilitator to facilitator. Third, SIL verification confirms performance only against stated assumptions. It does not prove that the original scenario basis was correct, that IPL credits were valid, or that field practices still match the calculation. Things may have changed, right? And fourth, last but not least, PSM leaders govern the integrity of the decision chain. You're it. They do not need to perform every calculation, but they do need to ensure the program is consistent, traceable, that your MOC triggers, that mechanical integrity is aligned, and defensible documentation exists. So the strongest programs do not let PHA, SIL selection, verification live in separate worlds. They maintain a clear line from scenario risk all the way to field performance. And that alignment helps avoid over-design, under-design, weak defensibility, and false confidence, which we've been talking about throughout this webinar series. So with that, I'll pause and open up for questions. As usual, I run a little behind. I do have a mini case that we can go back if you have time for that, but let's give an opportunity for folks to ask questions.
Yeah, don't be shy. I see that there's not yet any questions in the chat, but if you have any, please feel free to submit them.
So if a question comes up, let me know, Stephanie. I'm not monitoring that, but let me go back here real quick for this mini case. Okay, a passing verification can still rest on weak assumptions. So this is a realistic example. So imagine a high pressure scenario in a refinery, right? The PHA identifies a severe consequence. The team performs a LOPA, credits several layers of protection, decides that a SIL2 SIF is needed. Okay, we see plenty of that. The SIF is defined, the SRS is prepared, and again, the SRS contains all of that, the safe state, the how fast the reaction time needs to be, power, backup power, etc. A SIL verification calculation is performed. The calculation shows that the design meets SIL2, which is good. So at first glance, everything looks good, right? But during a later review, and this could have been a functional safety assessment, during a later review, several issues are identified. One credit IPL may not have been fully independent from the initiating cause. That happens a lot with BPCS cases or equipment that is shared between BPCS and SIS. Another may not have had the testing or auditability needed to justify the credit, right? We cannot test this. We cannot possibly test this often. We cannot shut this down as often as the SIL verification tells us that we must. The initiating event frequency may have been selected inconsistently compared with similar scenarios. The proof test interval in the calculation may not match what the MI program can realistically perform, what I said. So in that situation, the SIL2 result may not be the only issue. The real issue is whether the basis for assigning and verifying that SIL target was defensible. And in this case, is not anymore, right? This is an important distinction because sometimes the SIL value may not be obviously wrong. The verification may even pass, but the chain of reasoning that we've seen, the chain of reasoning behind it may still be weak. And that's why LOPA SIL assignment reviews can be so valuable. Functional safety assessment reviews as well. They do not just ask, did the calculation pass? They ask, does the risk basis, the SIL target, the SRS, the SIL verification, and the field program all tell the same story? And that's the basis of any functional safety assessment. We don't look just at, do you have this paperwork or not? We look at the paperwork, we check that you have the paperwork, and we analyze your paperwork to make sure that this story, your book, each SIF has a book, right? If we can think of it as a book from a PHA all the way to maintenance and testing records, we make sure that your book is coherent, is telling the story properly, right? It doesn't have any gaps, any inconsistencies. And so that's all I have.
We do have one question. During SIL verification, how can we ensure during LOPA IPL are verifiable, it also comes under SIL verification?
So under SIL verification, a lot of times, and I believe I mentioned this, a lot of times I get asked just to do a SIL verification, and then I'm given data sheets, I'm given loop wiring diagrams, I'm given technical information, right? And I go to the software, I model that loop, I model that safety function, and then I tell you whether you're meeting requirements or not from a hardware and installation point of view. That results in how often you need to test that. That results in the proof test intervals, proof test procedures, even if you want us to create that for you. But I usually like to ask questions. I usually like to understand. I usually ask for the LOPA, at least the LOPA. And if the LOPA is obscure, it's not clear enough, I ask for the HAZOP, because I want to make sure that that SIL that I'm verifying and I'm putting my name on it, saying that, yep, I blessed this, I'm stamping this guy here. I want to make sure that not only it passed, not only it is a SIL 2 SIF, because you're asking me to verify, Charlie, is this a SIL 2? Does it pass as SIL 2 according to IEC 61511? And I would tell you, yes, it does pass as a SIL 2. And then I usually follow up with, is SIL 2 what you need? Is this really handling the hazard scenario that started the entire chain, right? So I usually go back and to make sure, just to glance, at least glance in the LOPA, usually I'll see the answer right away. Oh yes, they made the right assumptions at the LOPA. This is exactly what this guy's doing, and it is acting as fast as the LOPA requires it to act. And again, if the LOPA is obscure, I'll go to the HAZOP. And if I don't see a good story there, if things are not making sense, are not coherent, then I raise an issue. And I say, I verified your SIL. I did you a SIL verification. However, there are red flags. And we cannot close this until you have an understanding that you have another issue at hand. A long answer to your question, but that's usually how it goes. And hopefully your question was regarding, how that process, what that entails.
All right, they say thanks, Shirley. All right, so I guess with that we are right at our time. So thank you, Charlie. Fantastic way to close out the series. You all came in today asking how PHA and LOPA results connect to SIL verification or selection and verification. And I hope you're leaving with a clearer picture and a better sense of how to make those connections more explicit and defensible in your programs. And so that brings us to the close, not just today of today's webinar, but of our 3-part functional safety series. So on behalf of everyone at Accutech and on behalf of Charlie, thanks so much for joining us today and throughout the series. The quality of your questions, your engagement across all 3 sessions, including the polls that made today's topic possible, made this a really rewarding program to put together. So a few closing items. The recording of today's webinar will be available in the next few days. We'll send you a link once it's posted. And like I said, if you miss either of the earlier sessions, both are now available. Links to webinar 1 and 2 recordings are on your screen now and will also be included in the email. All 3 sessions built on each other nicely, but each one stands on its own. So please do share them with colleagues who work in process safety or with safety instrumented systems. And if you need a PDH certificate for today's session, please email us at contact@accutechconsulting.com and we'll get that right out to you. And this concludes our functional safety for the spring, but this won't be the last time you hear from Accutech on these topics. So if today's session highlighted gaps in how your organization connects risk analysis to SIS design and verification, or if you're looking for support on SIL selection, SIL verification, or functional safety assessments, Accutech's team is here to help. So reach out to us at contact@accutechconsulting.com and stay connected with us on LinkedIn to be the first to hear about upcoming webinars, training courses, resources. We just this week announced a summer webinar series on 3 separate topics. And so thanks again, and a huge thanks to Charlie for the outstanding 3-session run. And we hope to see you at a future webinar. Thanks, everyone.
Absolutely. And if you didn't get a chance to ask your questions, formulate your questions on time, or even if you're watching this in a recording format, don't hesitate to reach out to us with your questions. Thank you, everyone.
Thank you.